Okay, boys and girls, today we're entering chapter number 10. It's about chapter 3, dynamic. So last week we're talking about the one is regarding the distance, displacement, the motion graph, acceleration, and so on. Okay, today dynamic topic is related with the force and mass. Okay, so we'll learn about Newton, first law, second law, and third law. Okay. So at here, before we start about the Newton's law, so we have to roughly recall back what we have learned about the mass and weight. Okay, so we look at that. Mass actually is definition is called amount of matter in object. Well, let me check the chat box. Okay, thank you. Okay, mass is amount of matter. You have to always remember, mass is always constant. Okay, the last one point at here, mass is always constant. So we can understand something like we have one head, two hand, and two leg. So this is the amount of matter. If we goes to the moon, we still having one head, two hand, and two leg, something like that. So that is amount of matter. So mass always constant, it won't change. Okay. Then the second one, properties of an object that resists the change in motion. So if your mass is higher mass, greater mass, then you are hard to change your motion. So this one will be related with the Newton's first law, talking about inertia. Okay, so you hard to change. If let's say you are sitting at rest, so your mass is higher, you are hard to change from rest to motion. Okay. So here, mass is a big scalar quantity. Scalar quantity meaning that there is no direction. Okay, we never say that mass is left, mass is right. No, there is no direction for mass. So it's scalar quantity. Base quantity. Okay, first lesson I already teach you. We have total 7 base quantity, but in our AS year 12, we need to focus on the 5 base quantity, and I already teach you how to remember this base quantity. Okay, I repeat, 1 kg of mass. Okay. So at here, 1 kg, this is mass. So mass is under base quantity. Okay. 1 meter, so this is length. 1 ampere, this is current. 1 second, this is time. 1 Kelvin, this is temperature. So the 5 base quantity we have to know. Others than this 5, actually still got another 2 like intensity and amount of metal. That one in year 13, okay? Except this 7 base quantity, others all are belongs to derived quantity. So weight actually is derived quantity. Okay, so what is weight? Weight is the gravitational force. It's the force due to the gravity. So for the weight, unit will be in Newton is because it is a force. Okay. So weight is always pointing downward. So it got direction. We have to consider direction. So this is a vector quantity. Okay, so weight, since it's derived, must be derived from some base quantity. So at here, formula for weight is W equals to mg. So at here, this one, G is 9.81 meter per second per second. Remember, your mass must be in kg. Okay, so for the mass and weight, this one is just recall because we learned already. So I just put one past year questions. So you try to do it, solve it. It should be no problem for you guys. Like try it and then tell me what is your answer. You type your answer to the Newton Scholar one. Don't type to the Dr. Low one. Dr. Low is my iPad. Okay. So I will check your message if you type in the Newton Scholar. So from there I can know. Okay, boys and girls, you try with this question. Only one question, then we're entering the Newton's laws of motion. John Ho say C. Okay, is it C? Others? Vashini say A. Yeah. Okay. So this one, gravitational free fall, you can say is A or G. It's the same thing. Then weight. Weight at here is W. Okay. So what is the weight on Pluto? Of course, Pluto weight, weight on Pluto, W equals to mg. Okay, the G for Pluto is here, this one. Okay, so what information you don't have, you have to find the mass. Okay, Fawel say yeah, A, yes. Okay, boys and girls, try again if you get wrong answer. Okay, so look at this, the weight on Pluto. So W equals to mg. Now I know the G is 0.66, but the problem is I don't know the mass. So you have to always remember the mass always constant. No matter on the Earth or on the Pluto, it will be the same. So mass, I can using this sentence to find out the mass. Okay, W on the Earth, this is on the Earth equals to mg. But teacher, I know this is this. I want to find the mass. I don't know the Earth. What is the G? We know. And they assume you know also what? Okay. On our Earth, it will be 9.81 meter per second per second. So at here, your mass should be 0.61 kg. This mass won't be changed. So we have to put it substitute it. Okay, we can substitute it at here 0.61 times the Pluto. This is Pluto weight, so 0.66. So your answer at here should be 0.40 Newton. Answer will be A. Okay, so can you see that two significant figure? Two significant figure. Okay, then we go to your page number 2. This one, page 1 is just recall. Page 2 is regarding Newton's law of motion. Okay, Newton, we got 3 law. First one is called inertia, law of inertia. Okay, inertia at here, if you are graduate from SPM, we learn this. Okay, if you are graduate from the IGCSE, we didn't learn about that. Maybe your teacher will be like mention and touch and go lah, but it's not in the syllabus. Okay, inertia is object at rest, it will keep on at rest. If object is already moving, it will keep on moving at constant velocity unless there is some external force acting on the object. Okay, so we look at this. If let's say here properties of the body is to stay in a state of rest or uniform velocity, yeah, this is called inertia. Okay, the mass is the property of an object resists the change in motion. This is the meanings when you're greater the mass, you had to change it. So we look at this diagram. This one, elephant, larger mass. You are the person trying to push it to move. At start is standing. So you want to push it to move. Do you think that easily? No. It's not very difficult. You change the motion. Okay, it's already at rest. You are trying to stay at rest. Okay, if let's say the elephant is running towards you, you trying to stop. Okay, sorry, you can't make it. Okay, it's very difficult for you to stop a very large mass object. This is called inertia. So it is at rest, it will trying at rest. If it is moving, then it will trying to continue moving in a constant velocity or constant speed. Okay, here this is about Newton. This is about Newton's first law, inertia. Okay, let me show you a video. I think, wait, let me check my screen. I think you can see. Okay, here, how to play with Oh, I didn't play the sound. It's okay lah. This is about inertia. Object at rest, it will trying to keep at rest. Okay, so this one, inertia, it trying to stay at the current state. Okay, it don't want to change. I didn't play with the sound because now I'm using my computer. Okay. Play faster. Oh, okay, here. Cover the important part and the pull. Inertia. All this is about inertia. Okay, lah, enough. Okay, well, let me share back my notes. Share the screen. Okay. So this is about inertia. Okay, inertia. So second part is called Newton's second law. This is related with momentum. Okay, this is related with momentum. So the rate of change of momentum. What is the meanings of rate? Okay, last times I already told you. Rate in physics means that per unit time. Okay, per unit time. Then after that, change of momentum. Change of momentum, that means that mv minus mu. Okay, so this sentence, rate of change of momentum, means that momentum changing divided by the time. So this is directly proportional to the resultant force. That's why we get this formula. F equals to mv minus mu over t. Okay, so this is Newton's second law. Said that the force actually is directly proportional to the rate of change of momentum. So if your change of momentum increase, then your force increase. Okay, so at here we know that acceleration is v minus u over t. So at the end we can get this formula lah, F equals to ma. This one we already learned. Okay, last time we have learned. Okay, don't forget this force actually is net force, or we say resultant force. Okay, resultant force. Then here, there is one thing that need to emphasize. Acceleration, sentence number 2. Acceleration, you see the whole sentence. I'm trying to emphasize at here. Acceleration and resultant force, they are always in the same direction. They are always in the same directions. So we look at this. Maybe I give some example. Okay, if let's say this is the car. Okay, the car is facing here, facing here. Okay, so okay, let's say at here moving forward is 100 Newton. I just simply give some value. So here is 50 Newton. Okay, what is the net force? The net force will be 50 Newton. Where is the directions? Here. Okay, so the car is facing to the left. Car is facing to the left. Where? Okay, so here it will be facing here. So your acceleration also in this direction. Acceleration also in this direction. Resultant force also here. So at here, you using your highlighter, you highlight this direction. They are in the same direction. Okay, move forward in the same direction. Okay, if let's say now is another case at here, the car still facing the same direction. Okay, here it's facing here. But the problem is now maybe we got strong wind blowing. Okay, so here thrust engine still 100 Newton, let's say only. Okay, then after that the move backward just now is 50. Right now maybe the strong wind blowing, so it will greater than, let's say, like 180 Newton, whatever. Okay, so at the end your resultant force right now actually it will be facing backward here. Resultant force will be here. Your acceleration direction also here. Okay, but right now actually in this case they are slow down. So you imagine you are running, okay, suddenly strong wind blowing. Okay, you won't move backward one, you just slow down because of the air resistance. Okay, so at here I want you to highlight this one direction and this direction. So this sentence number 2 is emphasized in the syllabus. You have to know that acceleration and resultant force, they are always in the same direction. Okay, so next we are going to try with the past year question. Okay, so if no question, then we try. Okay, is it okay? Or should I let you copy anything? If okay, then let me know. Okay, right here. Next, Here, this is the case that I mentioned just now. So you look at this, the car is traveling, then after that is facing to the right, okay? But you see the the thrust is 100, 1,200. But the air resistance or drag force or whatever, friction or whatever, they are greater than the forward force. So at here, doesn't mean that your car moving backward. No, it means that you slow down. Okay, you slow down. So at here, the question asking you to find out the magnitude of acceleration. So after you find the acceleration, we don't care about the positive and negative because now the question say magnitude only. So they want the number only. Okay, boys and girls, you try it right now using just now the formula F net equals to ma. So you try to find it out. What is the acceleration, magnitude of acceleration? Got one already get the answer. Good job. Okay, answer is A. Answer is A. Jahan, yes, correct. Okay, they all at here. We can using we can using the bigger force minus the smaller force. No problem, because if we only want the magnitude, doesn't care. Okay, so equals to the 850 A. So your A magnitude at here actually will get 0.47 meter per second per second. Okay, but at here is more the direction for the acceleration is here. Okay, the resultant force also here. But this one A actually is slowing down, deceleration. If we really writing it down, it should be a negative. Okay, but the question here answer just want us to write magnitude, so doesn't care. Okay, we just give the magnitude. Answer is A. Okay, so here, boys and girls. Okay, we look at this second question. Okay, this one, how we solve it? A mass of 5 kg is released from rest. So at here at rest, that means that starting is not moving. Then frictionless, that means that no friction. Angle inclined plane is with angle 30 degree. Air resistance is ignored. How far? How far, that means that distance. Okay, talking about distance. So for this question, actually they want you to combine what we have learned in the last chapter, chapter 2. Chapter 2, we got 4 linear motion equation. I write it here. 4 linear motion equation that we learned. V equals to U plus AT. S equals to 1 over 2 U plus V times T. Number 3, S equals to UT plus 1 over 2 AT square. Then the last one is V square equals to U square plus 2AS. Okay, you have to know. So that means that they want you to combine F equals to MA and also what we have learned last chapter. Okay, how far? So we need to find the S. So at here, they're giving us the time. Okay, so maybe I can write down what information we have. Starting is U equals to 0. Then how far we are trying to find S. Then the time is 0.8 second. Then one more informations we can find is acceleration. So right now we are going to find out acceleration first. Okay, before we apply this 4 linear motion equation, we have to find out the acceleration from this question. Okay, so boys and girls, I guide you how to do. Okay, so this one pointing downward, this is weight. W equals to mg. This is weight. Okay, so this one, the weight, we can resolve into 2 forces. One forces is parallel to the inclined plane. So here I can write like Fx. Another one is perpendicular to the plane. So I can write this as Fy. Okay, we can resolve these 2 forces. Resolve the weight into 2 forces. Okay, resolve means that split into 2 forces. Because I want to find F equals to MA. Okay, F net equals to MA. Our task right now is trying to find out your A. So this one, we have to find out the force which is same direction as your acceleration. So I need to find out this force. I cannot using the mg. Cannot. Okay? I know that this object is moving down like this. Okay? Moving along the inclined plane at here. So this is the acceleration. So what force I need to find out is this one, Fx. So I need to find this Fx. Okay? This one. With this, then after that, I can calculate the acceleration. Okay? Until here, okay? Okay, then next. Here, this is 30 degree. Here is 30 degree. So this one will be 30 degree also. Okay? If any of you asking why, okay, here, this one, here, this part is 90 degree. This one 90 degree. So that means that here will be your 60 degree. Then just now the Fx and Fy is 90 degree. So here if let's say 60 degree, then this part will be 30 degree. Okay? If you learn from SBM, then you will know this. But IG will never touch with this question. So that's why I need to explain in more detail. Okay? I need to find this Fx. So I need to resolve the weight into Fx. Okay, so this one, resolutions, lesson number 1, we already learned. If the angle is not between the two forces, we using sine. Okay, so Fx at here, it will equals to mg sine theta. Mg sine 30. Okay, then you will get your Fx. This Fx is your net force. Why is your net force? Because just now the question already told you there is no frictional force, no air resistance. This force is the only force. Okay, boys and girls, now I want you to calculate what is your A. You tell me your A value first. With the A, then we only can proceed to the linear motion equation. Try, then let me know your answer. Find out the A first, then only goes to the second step. Dear, I think just now I lose connection. I think just now I lose connection. So let me have a look. Any of you able to find 4.905? Thank you, Washini. Yes. Okay, so at here, this one. Okay, mg. M is the 5 kg. Then G is the 9.81 sine 30 degree equals to 5A. Your A should be 4.905 meter per second. Okay, because this value we are going to use it for the next part. So we won't be simplify it lah, trying to make more accurate value. Okay, then we get the A. So at here your A will be 4.905 meter per second. Okay, now I want you to think what value formula you are going to use so that you can find out how far the mass travel. Okay, so you look at this USTA. U no S. So first equation not using. US. UST no A. So second equation not using. UST A. Oh, okay. So we're using the third one. Okay, we're using the third one. So at here, S equals to UT plus 1 over 2 AT squared. So at here, U is 0, so we don't care. Then 1 over 2A 4.905 times the T is 0.x squared. So your answer should be 1.6 meter. Okay, is it okay? Third formula, thank you. Thank you, Vashini. Hey, Vito, good job. Okay, so boys and girls, any question for this? You think, do you able to get the answer, teacher? YA is not 9.81. Okay, dear, if object is falling down like this, then we are talking about acceleration of free fall due to the Earth gravity, then it will be 9.81. But the problem is, for the object moving left, right, or so on, slanted, they are not affected by the 9.81. Okay, only the object that you throw upward, we will say acceleration is negative 9.81. Throwing downward, we say acceleration is positive 9.81. Only this case, we say 9.81. Other than this, it will not only affected by gravity. Okay? Then horizontal, moving horizontal is not affected by the gravity. So the A is depends, and we calculate using the formula net force equals to MA. Is it okay, you think? Okay. Wow, okay or not? Let me check. Why is it 5A? Oh, because the object say that 5 kg of mass. W equals to MA. The object mass is 5. The object mass is 5. 5 kg object. Wow, is it okay? Object is 5 kg. Okay. So boys and girls, this one settle. Okay. But then before we proceed to the next question, here there is some space. I want to recall some important knowledge regarding the force. Okay, so we look at here. We take some notes. Force, we got two type. We got two type. One is called balance force. So here there is one called balance force. Another one, we call it as unbalanced force. I need to recall first because later on the question will be related with this concept. Okay, but this one we already know. Just recall. Okay, so if balance force, let's say I draw my object like this. Okay, so let's say moving here is 10 Newton, moving here also 10 Newton. So I will say that my resultant force or net force is 0. This is balance. The force is balanced. Okay, so if force is balanced, the motion, we got two type of motion at here. One is maybe object at rest. Second, maybe object moving until a certain moment it balance. So at this moment it's moving with constant velocity or constant speed. Okay, this is balance force. Unbalanced force, okay, I draw it out. Maybe object like this. Here moving 10 Newton. Here is, let's say, 4 Newton. Now my resultant force is 6 Newton. Right? It no longer 0. If no longer 0, here that means that F equal here, F equals to MA. F is net force, F equals to MA. If your force is not 0, then your acceleration value won't be 0 also. So at here, they have three types of motion that is possible under the unbalanced force. One is when your A is positive, then we say it is accelerating. Object is accelerating. Second one, if your A, second one, if your A is negative, we say object is decelerating. And third case, maybe object is moving in circle or maybe it's changing direction. It all belongs to unbalance. So this concept we recall back later on when we're answering the behind questions, we will relate it with this concept. So I need you to recall it down. Until here, okay? If okay, then we are going to proceed to page number 4. Okay, thank you, Junho. So no problems, no problems. We go to page number 4. So here, okay, page number 4, 2 blocks. So we're also trying to using our knowledge about F equals to MA to solve this question. So here there is 2 blocks. One is 0.2, another one is 0.5. So here they will have a pulley, frictionless. That means that no friction. Okay, the block are initially hold stationary. The block of the mass 0.2 kg at rest, starting at rest. Okay, then on a rough surface. Rough, that means that it will have friction. Okay, it will have friction at here. So you look at this object, 0.5 kg and 0.2 kg. Of course, this one heavier. It will pull it down. Okay, it will pull it down. So that means that here, the weight at here, it will be greater than your tension. The force in the string we call as tension. So along the tensions, their force of tensions at any single point in the string will be the same. So this is the tension. So you look at this block will moving downward, pulling the object downward. That means that this object will move to the right because they are moving together one. Okay. So here, this one are using red color. So it will accelerate in this direction A. So this one will moving downward, acceleration at here. Okay, so at here, 2 things you have to remember. The tensions at here and here, they will be the same because they are same string. Okay, then after that, the accelerations are the same because they're moving together. Okay, these 2 concepts. So how we solve this question, we can divide it into 2 parts and we draw it out and see we're trying to draw it up, separate it and finding some unknown value. Okay, let me have a look which one we are going to try first. Okay, trying to separate the right hand side moving downward. So I draw it here. Okay, the object moving downward will be your weight. This is your weight. The force pointing downward is your weight. Then there is one string pulling upward. This is your tension. So we understand that the 0.5 kg is moving downward. So that means that the weight will be greater than your tension. So net force equals to MA. We understand object moving in this direction. That means that the weight will be greater. So we're trying to find the net force, which using W minus the tension. Okay, W minus the tension is because weight is greater. How I know weight is greater? Because I know that it's moving downward, accelerate downward. So weight must be greater. Equal to the MA. The M at here is represent this one, the object moving downward here. Okay, so this one W equals to mg. So we're using 0.5 times 9.81. Tension, we don't know. We just left it here. Okay, the mass, because now I'm calculating this part, I divided into 2 parts. I'm using this part. Okay, then M, the mass will be the 0.5. Then the question tells us that acceleration is 2 meters per second per second. So I just substitute in. From here, we can calculate the tension. Tension is one type of force. The force that transmitted in the string, we call it as tension. So we're using the symbol of T. From here, you can calculate the tension. Then after that, the second part at here. Okay, we look at the second part. This is the object moving, tension pulling. Then here we got friction. Question asking you to find the frictional force. So right now this object is 0.2 kg. Again, net force equals to MA. Net force at here, I need you to think which force is bigger force. Where it moving? Where is the object moving? Moving in this direction, right? So that means that we understand the tension must be greater than friction. So at here, T minus friction equals to the M. M is 0.2. A is, question told you, is 2 meter per second per second. So boys and girls, we want to find the friction. Therefore, we need to know the tension first. You see, I need to know the tension first before I finding out the friction. So you have to solve the number 1 at here, finding the tension. Then this tension substitute in, then you're trying to find out the frictional force. For this question, we can split it up, okay? Split the two diagram, but you have to understand the tension is the same, the acceleration is the same. Okay, you try to do calculation and then tell me your answer. But wow, so fast. A, correct. The rest of you try. Kai Qian A. Rashini A. Oh, very good. Okay, here, this kind of question, experience student, we did it. But the IG, we never touch this kind of question. That's why I need to explain in detail, slow down. Okay, in case somebody at here, students at here, you are graduate from the IGCSE, so I need to slow down. Okay, here, this answer, it will get 3.905 Newton. So we put it in, at the end at here, we will get 3.5 Newton. Answer will be A. Okay, any question? If you got question, type and then let me know. Type in the chat box and let me know. No question, Any question? Can I proceed? Can, thank you, Vashini. Okay, the rest okay, You didn't respond, then I assume everybody call. Okay, for a while, let me have a look. Can, thank you. Okay, dear next. This one something new, but not difficult. A block is moving along the horizontal frictionless surface. A constant force is applied and a constant resistive force 5 Newton act on the block as it is moving in the directions of the force. Although it's frictionless, but maybe the resistive force at here is meaning that air resistance. Okay, so here continue the graph showing the variations with time of the momentum. Okay, so at here, momentum and time. Basically, every time we're talking about graph, we are finding two things. Either we're finding the gradient or we're finding the area under the graph. Okay, so we look at this. For this graph, momentum, if we're finding the gradient, which is momentum, change of momentum divided by the time. So gradient actually finding what? Change of momentum divided by time, we are finding the force. Force changes. Okay, the gradient actually is finding the force. So boys and girls, can you try it out to find out what is the magnitude of force? Please be careful with this question. Try. Read the question again and then trying to find your answer and then tell me your answer. Let me check how many of you can get the correct answer. Boyang say A. Wow, very good, Boyang. Joray, let me see your answer. A, good job. Others? A also, wow. Good job, Everybody can do it very well. Okay, here, The gradient is 1.5 minus 2.7 divided by the time is 0.4. So if not mistaken, you'll get negative 3 Newton. Okay, so at here, the net force at here is the phi minus the F. So this one negative 3 equals to phi minus the F. So your force should be, oh, no. Wait, let me have a look. F minus, here, wait. Should be F minus the 5. So at here is F minus the 5. So the force should be 2.0 Newton. Two significant figure. Okay. So at here, you look at here, momentum decreases. That means that the speed decreases. That means that now it's deceleration. Okay. Deceleration, now we double check. Although object is moving to the right, but this actually is deceleration, is a negative value. This one you will get a negative value. Okay. So wait, let me have a look. Oh, okay. This one is they slow down. Changes of momentum, you see here, momentum become decreases. That means that the speed is decreases. So we know that is right now is deceleration. Deceleration, that means that the force here must be bigger. Okay, so 5 minus what, you will get the 3 Newton. So answer will be 2 Newton. This one is we can use it to double check our answer. Okay, we can double check our answer. Okay, so until here, let me try. Any of you got any question? Vashini, A, okay. Any others? If no, we are going to the structure question, page number 5. Any question you want to ask? If no question, respond to me also. No question, thank you. Okay, so boys and girls, we go to the next question. Page number 5. Okay, structure question. A block is pulled by a force X. So we're pulling in a straight line along a rough surface. So it will have frictional force. Okay, here, assume that the total resistive force opposed the motion is 0.8. So this is a constant value, 0.8 at any speed. Okay, all the speed will be the same. So the variations with time t of the magnitude of the force x. Okay, this force will change. In the first 3 seconds is 1.4. Okay, maybe I can write it here. At the first 3 seconds, the x here actually is 1.4 Newton. Okay, then after that, from 3 seconds to 6 seconds, it will be at, here is 0.8. The force will be 0.8 Newton. Okay, so the force will change. Then after that, look at here, define the force. This one easy lah. Just now we got mentioning F equals to mv minus mu over time. You don't tell me that the force definition is the product of mass and acceleration. This is wrong definition. Definition based on this. Okay, so just now I got teach you about the rate. Rate meaning that per unit time. So at here, this is rate of change of momentum. So this is the correct definition. No need to memorize. As long as you understand this is from this formula. So from the formula, they define it. Okay, determine the change in momentum. Momentum is changing from the time t to t equals to 0 to 3 seconds. Okay, boys and girls, can you try it right now? Trying to find the change in momentum. Try to find out what is your change in momentum. Prasan say 1.8. Correct, dear. Correct. Okay, the net force, F is net force. So in 0 to 3 seconds, what is your net force? That's why just now I label it down. You see, in the first 3 seconds, the force at here is 1.4 Newton. In net force, you should minus the resistive force. Again, the net force, you should minus the resistive force. So which means that at here, it should be 1.4 minus 0.8. So it will be like this. The X at here is 1.4 Newton. Resistive force is 0.8 Newton. So at here, the net force actually minus it. Okay, minus it. So at here, change in momentum, which is mv minus mu. So 1.4 minus 0.8 times 3. Your answer should be 1.8 kg meter per second. Okay, others than Prasan, any others cannot get the answer? Is it okay for this question? 0 to 3 seconds. X is 1.4. Resistive force at all the speed will be 0.8. So we minus it. Okay, apply the formula only. Any of you got questions? If no questions, respond to me. Then we proceed to the page number 6. Okay, thank you. Okay, so we goes to the page number 6. Describe and explain the motion. Motion, how we describe? Object at rest, object moving with constant speed, object accelerating, decelerating. This is about describing the motion. Okay, from 3 seconds to 6 seconds. So here, 3 seconds to 6 seconds. How you describe the motion and why? Describe and explain. So you need to explaining the reason why you say so. So type your answer on the chat box. 3 seconds to 6 seconds. The X actually is 0.8 Newton. So at this moment, what is the motion? Is it object at rest, accelerating, constant speed, decelerating, or how? Like boys and girls, type your answer in the chat box. Or you need me to give some hints? Let me check. Decelerating? No. Constant speed, Kai Qian, correct. Fawal, let me check. Constant speed because resistive force and force X is the same. Good job. Okay, dear, look at here. Good job. So look at here. 3 seconds to 6 seconds, the X is 0.8 Newton. The opposite direction force is also 0.8 Newton. So this one is what just now I mentioned. It will be a balance force. It will be a balance force. No resultant force. Of course, you know A. They will have two possible answer, at rest or constant speed. But because this object is moving, it is moving. So at here, so starting at here is moving, right? Here moving. So until this 3 seconds to 6 seconds is still moving with constant speed. Okay, here we answer the questions. So what is the constant speed here? 3 to 6 seconds is constant speed or constant velocity. Okay, doesn't matter. Then reason is just now Fawal say resistive force X and Y is the same. Yes, correct. Or in another way, we can also say that because they are resultant, force is 0. Resultant, that means net force is 0 lah. Okay. If I will write like magnitude of resistive force and force X is the same but acting in opposite direction. But your answer is okay lah. But I will write in more detail opposite direction so that we know that cancel out each others. Okay, so for this one, 3 to 6 seconds here, just now is 0. Is it X4? Let me have a look. What is this? 0.8 Newton. So this one also 0.8 Newton. So at here, this is balance force. Net force is 0. Resultant force or net force is 0. So your acceleration also 0. It didn't accelerate, it didn't decelerate. So two possible answer, maybe it can be at rest or moving with constant velocity. But why we choose constant velocity is because object at start already moving. So 1 point starting here 1.4 minus the 0.8. So at start 0 to 3 seconds is accelerate. Here is accelerate. After that, here is constant speed, is moving. Okay. Next one, need you to draw sketch the graph. Okay, here. The block is at rest at time t equals to 0. So starting is 0, starting is at rest. U at here is at rest. Sketch the momentum against the time from 0 to 6 seconds. Okay, boys and girls, can you try? Then after that, you roughly told me how was your graph. Try first. At start, no velocity because at rest, then of course momentum is starting is 0. So we will start at 0 here to sketch your graph. So at here, try first. Although no need calculation, but I still trying to calculate it out. Okay. So if you already sketch your own graph, then you can compare with mine. Although they say that no need to calculate it out lah, okay? But here, calculate it out is more easier for you to know how we get this graph shape. Okay, at start, time equals to 0. Object is at rest. So here, object at rest. So that means that at starting, there is no momentum. So we will start at here, 0. Okay, we will start at 0 here. Then here I put the time is 3. I want to find out what is the momentum after 3 seconds. So we understand that after 3 seconds, at the 3 second, we still 1.4 Newton to the right, 0.8 to the left. So after substitute the value into the force is equals to change of momentum divided by time. So change of momentum, we just using force times time. So now I'm using force times the time. Okay, force times the time. So I will get 1.8 kg meter per second. So that means that maybe roughly somewhere here lah. Okay, 3 seconds is somewhere here. Okay, so somewhere here. Let's say 1.8 is here. Okay, then we plot the line, horizontal line, because it's increasing. Okay, time 1 second, 2 second, 3 second. Okay, then after that, at the 3 seconds, starting from 3 second to 6 second, this one, the force is already balanced, 0.8 Newton, and another one also 0.8 Newton. So if you do substitution, you will find that change of momentum is 0. What does it mean? There is no changes of momentum. It will maintain the momentum. Okay, object still moving with constant velocity. So your momentum won't be 0. It just changes of momentum does not change. It's 0 for changes of momentum. Okay, momentum at here you cannot draw to 0. It is where okay, it is maintain the momentum. So we maintain the momentum. So your graph should be like this. Okay, for this part, object moving with constant velocity. So confirm it will have momentum. And the momentum is constant momentum. Okay, momentum does not change. No changes of momentum. So your graph will be look like this. Any question for this one? Fatima? No, good job. Okay, others? Do you have any problems with this, sketching the graph? No, thank you. Okay, so boys and girls, we go to the next question, page number 7. Page number 7 is the opposite to this question, question number 5. Just now is we give you the force, then we want you to find the momentum. Next question is they give you the momentum, but then later on they want you to sketch the force. So, but the idea is the same. Idea is the same. So we go to your page number 7. Okay, a block is pulled in a straight line along a raft. That means that we got frictional force, okay, by varying force. This force X will change, will change. So next, air resistance is negligible, so we ignore the air resistance. Assume that the frictional force on the block by the surface is a constant and a magnitude of 2 Newton. Okay, you see it's moving in this direction. So your frictional force will always in the opposite directions to the motion. So this one is your frictional force, which is 2 Newton. Okay, label it. Okay, so here, this is the momentum. So later we come back and trying to go through with this graph. Here, state the Newton's second law of motion. So this one already give you the answer. This one is talking about F equals to mv minus mu over t. So the force actually is directly proportional to the rate of change of momentum. So this is rate of change of momentum. Okay. So if you are smart enough, actually a lot of definition no need to memorize. We can get from the formula and then explain out based on the formula to explain out. Okay, so here we go to this. Using the figure 3.2 to determine for the block at the time 2 seconds. Okay, at 2 seconds here. At 2 seconds here. So what information we can get? Okay, then after that, what they want us? Determine the magnitude of resultant force. So boys and girls, can you try and then type your answer? Try first before I let you know the answer. Okay, here, is it this? Okay, so next. My boys and girls, after you complete the first answer, let me know. What is the resultant force of the block at 2 seconds? 2 seconds. As I told you, graph information, we got two. Either we can get some information from gradient or area under the graph. So you have to go through and think, hey, this gradient, what information we can get? Okay, Vashini, yes, correct. Your answer is correct. We're waiting for others. Any others? Do you able to get the answer? So we're trying to look at this gradient for this momentum time graph. Gradient, we will using y2 minus y1 divided by x2 minus x1. This is mathematics. So in our y-axis at here, actually is change of momentum. Then your x-axis is your time. So change of momentum divided by time, this gradient actually we're finding the net force. This is the net force. So boys and girls, can you calculate the gradient? And then what is your answer for your resultant force? 1.5 Newton. Thank you, Fawal. Yes, correct. Okay, so boys and girls, this is a constant gradient. So we can finding by finding this triangle. You see this one triangle. So I can using this gradient is equals to the net force. So my gradient, let's say I using this triangle, big triangle. Okay, so this point will be 4, then 6, this one will be 0, 0. So that means 6 divided by 4, I will get 1.5 Newton. This is the answer for B1. Okay, this is the answer for B1. So next, the question asking you to find the force X. So I slightly move up. Look at this. What is your force X? Your resultant force is 1.5 Newton. What is your force X? Okay. Type your answer and let me know. Wow, good job. Others? Any others? Can you tell me your answer? Yes, Vashini, correct. How about others? Prasan, Boyang, Yue Ting, Fatima, what is your answer? Resultant force, 1.5. That means that resultant force, 1.5. What is your X? Boyang, Boyang, do you get the answer? Jore, 3.5 Newton. Thank you. Okay, dear. B2. Okay, here. This one, that means that resultant force is 1.5 Newton. Then this is your X. Here is 2 Newton. So resultant force will be X minus 2. Then after that, 1.5 equals to X minus 2. So your X should be 3.5 Newton. Okay. So boys and girls, I want you trying to sketch the graph of force X. Now it's different, opposite way asking. The way they're asking is opposite like just now, question number 5. You think correct? 3.5. Thank you. Okay, Lion Deal, try to sketch your graph. From 0 to 4 seconds, what is your force X? Read the question carefully. Now they're asking you is force X. We sketch the graph for X. How was your graph? You able to sketch? Okay, so just now we already calculate your X force is 3.5 Newton. So at here, from 0 to 4 seconds, this part, the X should be 3.5 Newton. So at here, 3.5 Newton until 4 seconds. Then how about 4 to 6 seconds? Any of you type your answer, let me know. Which value of X I should draw the line? Change to 3.2, then 3. 3.2 to 3? No? No, no. So you look at this, You look at this, here. Momentum maintained. No change in momentum. No change in momentum, that means that what is their motion? Recall just now the question number 5. No change in momentum, that means that the velocity does not change. So it is constant velocity. Use this idea. This one, I take some note. This is unchanged. So U and V are the same. That means that constant velocity. So, yeah, vowel, correct. How about others? What do you think? I give you some hints already. Second section here, there are no change in momentum. They are moving with constant velocity. So what is your force X? After 4 to 6 seconds. Yeah, correct. Gradient is 0. So there is no changes, no changes of momentum. Washini, 0 Newton? No, no, it's not 0 Newton. I draw it here. Constant velocity. Recall just now at start I asked you the empty space. You recall it down. Force we divided into 2. Balance, unbalanced force. Constant velocity belongs to which force? So at here they tell you this is 0.2 Newton. What is your X? Is it your X is 0? 4 to from 4 seconds to 6 seconds. What is your X value? Let me check others. Fatima, constant increase to 5 Newton. Increase to 5 Newton. If here is 5 Newton, dear. If here is 5 Newton, then it will be some value and accelerate. If it accelerate, it won't be a constant momentum. Constant momentum, that means that mv minus mu, the v and u are actually no change. It's constant velocity, meaning that constant velocity. The motion is constant velocity. Constant velocity means what? Just now the short note. Balance force or unbalanced force? Yeah, let me have a look. Yeah, balance force, Kai Qian, but not 0.2, Oh, sorry, my fault. Dear, my fault. Yeah, here is 2 Newton, not 0.2. That's why I make you confused. Here, 2 Newton. Sorry, not 0.2. So what is your X? Yes, correct. Balance force. So this part, Washini correct already. Here, it should be 2 Newton. It should be 2 Newton. Okay. So I repeat, you have to digest and think. Okay, here momentum does not change. Momentum does not change. It remains the same momentum. Momentum is mv minus mu. If it is no changes, because no gradient, no changes, this one is 0, this one 0, meaning that this one mv minus mu also 0. That means that the v and u are the same. They didn't change. Okay, if u and v are not changing, that means that they are constant velocity. Constant velocity, this is balance force. balance force, net force is 0. So your X should be equals to 2 Newton. Okay, this is 2 Newton. So we goes to the graph at here. We should draw like this, 2 Newton. 4 second to 6 second, 2 Newton. Then this one we draw a vertical line. Yeah, this is the answer. So this one, this part is X is 2 Newton. Resistive force is 2 Newton. So actually it's moving with constant velocity. Okay, momentum is constant. Momentum no changes. Is it okay for this question? The front part is 3.5 is because just now we calculate one. Okay, at here we already calculate. At the end we get 3.5 Newton. Okay, here. Any question? Type it out if you got facing any problem. Or you need me to go to the front page here. If you are not clear, then take some note. Next time when you do revision, more easier. Here, why we get X equals to 2 Newton? Because changes of momentum actually is 0, no change. Okay, momentum no change. So U equals to V, velocity does not change. That's why momentum also remain. So constant velocity. If constant velocity, the net force will be 0. X should be equals to 2 Newton. Okay, can I proceed to the page number 9? Respond to me. Can, thank you. So we proceed. Okay. Junho, yes, okay, thank you. Like boys and girls, we goes to the next one, page number 9. So we already talked about Newton's first law, Newton's second law, and then now we're talking about Newton's third law. Newton's third law is about action and reaction. Okay, so at here, we should emphasize few things. Two objects. Must be two objects involved. Then they will have equal force. That means that equal magnitude, opposite direction. Okay, so this part this part number 2 requirement, this one important. Okay, so what is the requirement? The force does not exist individually, but is in pair. In pair, that means that two objects. The force act on different object. It will acting on different object, and then must be acting in opposite direction. The force are of the equal magnitude, same magnitude. And then there must same type of force. Same type of force. Okay, so at here, we look at some example. Okay, highlighter here. So this one involved with two objects. You see, the pot is object A. Then the table is object B. Then after that, the wall is object A. Person is object B. Then here, the nail and the hammer is object A, object B. So for Newton's third law, it will involve with two objects. Okay, then you see this direction. Okay, the direction at here, they must be opposite. The size that draw the force, they also draw in equal size to represent that same magnitude. Magnitude means that value lah. Okay, so at here, this is example. Okay, Newton third law, not only for the contact. Now the example that you saw is actually in contact, they touch each other's, but also for non-contact. For example, the diagram actually is here, this one, in the next page already. So this is example non-contact, the object doesn't contact each other's, but this one also example of Newton's third law. Okay, so this one see gravitational force. In between them is gravitational force. So acting on two objects, our moon and our earth. Okay, it's two objects. So magnet, two magnet. Proton, two proton. Okay, object A and object B. So next, come back to here. Okay, so this one number 4, sentence number 4. The force on the object will be negative if the direction of force is opposed to the initial motion. So force is vector quantity, is also got direction. We need to consider direction. Okay, if you oppose your initial motion or initial velocity, then we put negative to showing that is opposite it. Okay, opposite to the motion. So you look at this is negative. So you see magnitude is 300 Newton. Magnitude is 300 Newton. The negative showing opposite direction. So we got two objects, object A and object B. This one is Newton's third law. Okay, then here, this one I want to make a star. Okay, in past year, when we go through more and more past year, we'll find that they like to ask you to explain. If they involve with Newton's third law, this is a very important sentence. They ask you to explain. So we have to say that the force exerted by object A, let's say object A, on the object B is equals and opposite directions to the object B acting on the object A. Here, you have to mention object A acting on object B. Then the magnitude is equal. It is opposite directions to the opposite way we're talking about the force. So we got two objects. This sentence, you have to take note. Later on, got past year question, we will using this sentence also. Okay, now we go to the past year question, page number 10. Can I proceed to the page number 10? Let me know. Okay, thank you, Junho. Thank you, Vashini. Okay, thank you, Prashan. Okay, like dear, go. So, I didn't erase the answer. I give the answer. Wait. Okay. Okay, boys and girls, I accidentally give you the answer. It's okay. Okay, this is, can you see that? This one is two object, and then their force is gravitational force, and then their magnitude is same magnitude, opposite direction. So B is Newton's third law. ACD all are wrong is because all the forces that mentioned at here actually is acting on the same object. Driving force due to the car, resistive force acting on the car, so it's still on the car. Okay, so this is not Newton's third law. Then this one is talking about the support force on this block, so it's still talking about the block. Then this one lift up force, the weight is still talking the aeroplane. So ACD, they didn't involve with two objects. So ACD is not Newton's third law, only B. Okay, although it's not contact, but doesn't matter. Okay, can be contact, can be non-contact. So we go to the question number 2. Here. Okay, you guys read it and then type your answer. A book of weight W is at rest on the table. A student attempts to state Newton's third law of the motion by saying that action equals to reaction. If the weight of the book is the action, the weight is action, then what is the reaction? Let me check. What is your answer? Vashini, correct? Fawal, no. Fawal, no. Prasan, correct? Boyang, no. Junho, no. No. Kai Chen, no. Fatima, correct. Boyang, no. Let me check. Do you think no? Okay, no, okay. So here, Let me say one more. Try. Let me. Jory. No, Jory, no. Vito. Vito, correct. No, farewell, no. Okay, dear. Any more message? Let me have a look, Bo Yang. Bo Yang, no. Bo Yang, you skip the correct answer, Bo Yang. Okay, dear, look at here. The weight on of the book. Answer actually is C. The weight is due to the gravity pulling, right? So and right now is from the book acting on our earth. Okay, so we got two objects. Object one is the book. Then object two is actually our earth. Our earth pull the book down. Okay, that is the weight. Now is the book acting upward force on the earth. So answer is C. Okay, weight is actually acting on the book. Weight is acting on the book. The earth acting on the book. So now it's on the earth due to the book. Just now weight is the on the book due to the earth. You get my point or not? Weight is the earth pulling it on the book. So now should be acting on the earth due to the book. Is it okay? If you get my point, then type it out. Let me know. Just now, who get wrong for this question? Did you get the idea? Like Boyang, okay, Boyang. Then any Fawang? Do you able to get the idea? Yes. Okay. Good job. Kai Chen. Okay. Get the point, Okay. Then, like boys and girls, we look at this. Actually, when we go through to the past year, a lot of this kind of question ask you to state how Newton's third law apply. Okay, so I just take one example, but actually this kind of questions is quite often to come out lah. Okay, so the ball is thrown vertically downward to the ground. So at here we got two objects. Object A is the ball. Object B, it acting on the ground. So we write ground. Okay, state how Newton third law. Okay, so just now I told you we are going to apply this sentence here. So how we say? We will say the force exerted by the ball on the ground is equal in magnitude but opposite in the direction to the force exerted by the ground on the ball. So this sentence we copy, but here we change. This four we change. So by the ball on the ground, by the ground on the ball. You get my point? That's why I asked you to make some star. Take note, this sentence is important. Okay, so we write it here how the Newton third law applies. So we write it together. Force exerted by the what? On the what is equal in magnitude and opposite direction to the force exerted by the what on the what. Okay, so here I empty is because, okay, object A on the object B. Object B on the object A. So the force exerted by the ball on the ground is equal in magnitude but opposite directions by the object B. Now it's ground acting on the object A ball. Okay, this kind of question quite often asking, but just put one example enough. Actually, you just change the object A, object B, that's all. If okay, then let me know. Can we proceed? Okay, thank you, Fatima. Yes, Power, thank you. Thank you for responding. Because you respond me, then I only know that you're done. Then we can proceed. Prasan, thank you. Mm. Vashini. Okay, Lydia goes to the next question. A small remote control model aircraft has two propeller. Each diameter is 16 cm. Figure 3.1 is a side view. Okay, from the side. A is propelled vertically downward so that the aircraft hover at the fixed position. The density of the A is this one. Okay, so we're finding the informations. So this is the density. So first density is 1.2 kg per meter cube. Assume that the air from each propeller move with a constant speed. So underline constant speed. This is V. Constant speed in a uniform cylinder diameter. Okay, so that means that something like here, cylinder. Okay, something like this. They propel the air particle down. Assume that the air above the propeller is stationary. Okay, so in the time interval 3 seconds, write down T. So this is density. Okay, the mass. Oh, for one only. They want you to calculate one mass for the mass of air particle. Prove that is 0.55 kg. So at here, you got density formula. Remember, density is mass divided by volume. You want to find the mass. At the end, you want to prove that the mass is 0.55. So first, density is 1.2. But the problem is, what is your volume? So boys and girls, this one, uniform cylinder of diameter 16 cm. So you have to calculate it out. What is this volume? So what is the volume formula for the uniform cylinder? So this one, oh, volume should be pi r square times the h. H is this. Okay, h is this. So what they saying? Okay, can you guys try to calculate it out? How to calculate the h? That is an important question. Give you some hints. H is the length or distance. So you can using speed equals to distance divided by t. You find the distance actually is the h. Like boys and girls, try. Check whether at the end you can get the mass or not. If you're able to prove, then you show me. You type and tell me that you can prove. Give you 1 minute to solve it. The difficult part is here, the h. How we find the h? But then we know the time is 3 seconds. We know the speed, so we know that the h. If you're able to prove, then you tell me. Type in the chat box and then say yes, proof. (16 cm), don't forget to change to the radius and then in meter. In meter. H is how far it travel. Okay, how far is push it down. H. So at here, it should be the speed times the time. Using speed times time, you can know the H. Do your calculation. Bashini, good job. Yes, Kai Chen, good job. Okay, now it's only calculate one. So if you follow this, now the difficult part is how we find the h lah, volume for the h. H is how fast it travel, 7.6 meter per second. So we got 3 seconds, we use 3 seconds. So using these two information, V times T, we can get the h. Okay, so we get this answer. For those who cannot, then you refer to my answer working step and check which part that make you like difficult. But then this kind of question is good. Even though A we cannot prove, but then we know that the mass for the A is 0.55, then we can proceed to use this value for the question, the rest of the question. Okay, line boys and girls, B. Calculate the increase in momentum of the mass of A in A. Calculate the momentum of mass. How much is increase? Why we say increase? If not mistaken here initially, let me have a look. Yeah, change of momentum. Initially, the mass of the A particle is not moving. Then after that, we move it. So at here, change in momentum. So change in momentum divided by time actually is the, change in momentum. Change in momentum actually is changing of mass times the velocity. Momentum is mass times velocity. So they want us to using the answer in A. That means that we have to using this 0.55 times the velocity. How fast the velocity moving? 7.6. So here 7.6. Our answer for this question should be 4.2 Newton second. Okay, for momentum, we will have two unit. Two unit. One unit is Newton second, or another unit is kg meter per second. Both unit are the same. Okay. If from 4 or year 10 we learn Ft equals to mv minus mu. So if this one mv minus mu, it will be kg ms negative 1. If F times T in pounds, this is Newton second. So these two units are the same. Okay? So, like boys and girls, calculate the downward force, the force exerted on the mass of A, on the mass of A. Okay, calculate the force in 3 seconds. Like boys and girls, calculate and then tell me your answer. Force related with momentum, and then they give you the time is 3 seconds. So how you solve it? But one correct, 1.4 Newton. Okay, here change in momentum divided by the time. We know that the time is 3 seconds, momentum is 4.2. So at the end is 1.4 Newton. 1.4 Newton. So one question to another question, they're related to each other. You see, we're using the 4.2 just now we calculate. Okay, so we go to your page number 13. This is downward force acting on the mass of A. On the A, this is 1.4 Newton. So, next question asking you upward force. Just now it's downward force. Now it's upward force acting on the propeller. So, can you guys type it out your answer? What is the answer? Just now it's downward force on the mass of A. Now it's upward force on the propeller. So what is the force for the propeller? Jore, correct. 1.4 Newton. Can you tell me how you get this answer? Why you say it's 1.4 Newton? Why? Name the law that explain this B1 and B2 and C1. What is the law you involve? Why you say just now is 1.4 right now also 1.4? What is the law you use? Tell me your answer. Thank you. Newton third law of motion. So you see, just now acting on the mass of A, now is acting on the propeller. Just now is downward force, now is upward force. Opposite direction. Two objects, A and propeller. Then they are same magnitude. So 1.4 right now also 1.4. Okay, now they're asking you to determine the mass of the aircraft. Okay, mass of the aircraft. Look at this. Okay, then this question involved with one thing. How was it motion? Look at this. Constant speed. When constant speed, they want to find the mass. So the whole propeller here, the propeller here, let me have a look. Okay. One propeller upward force is, let me draw it out like this. Let's say, one propeller going out is 1.4 Newton. We got two. You see, this is only one, but the aircraft, we got two. Okay, the question asking you, what is the mass of the aircraft? Like boys and girls, it is moving with constant speed. So relate what I told you just now, constant speed, the force is what? Then it's balance or unbalanced. What is the resultant force? What is your downward force? What is your mass? Do you able to calculate and then tell me your answer? I give you the hints already. Here we got weight. But how I know my weight? How I know my weight? Do it and then tell me. For a while, let me check. I need to press my calculator. Let me check. My one. Two significant figure, Phá không? Yes, correct. Phá không get the answer already. How about others? Keyword at here. The propeller move with constant speed. Constant speed. This motion is constant speed. Constant speed meaning that the force is balanced. Correct, correct. Fatima, no. Okay, no. Must be something wrong. Then you try again. Okay, constant speed meaning that the force is balanced. Balanced force. Resultant force will be zero. That means that your upward force must be equals to your downward force. Your downward force is the weight of the aircraft. So at here, your upward force should be 2 times 1.4 equals to your weight is mg. M times 9.81, 2 times 1.4. So your M at here should be 0.29 kg. So just now one of your friends told me 0.31 significant figure, don't. Okay? 2 to 3. So we accept 0.29 kg. Don't write 0.3. Okay, so this one, the answer is here. Is it okay? Digest. Think again. What is the weight? From the weight, we can know the mass. So what is the weight? Then how I know the weight? Upward force equals to downward force. Why? Because object moving with constant speed. So the upward force provided by the propeller for one is 1.4. But we got two. Don't forget we got two. That's why they keep on mentioning one at the front, also talking about one. But at the end, we got total is two. Okay, any question? Vashini, okay? Okay, thank you. Okay, dear. In order for the aircraft to hover at a very high altitude, going up, so the propeller must propel the air downward with a greater speed. It needs to have a greater speed. Okay, compared to the low altitude. At the low altitude, no need to be so fast. Just now the speed is we using 7.6 meter per second. Right now is we need to greater than 7.6. Maybe we need 10. Okay, so at here, can you tell me, suggest why when we going to the higher altitude, we need to like moving faster. Okay, propel the air particle downward faster. So at here, give you some hints. When we trying to go higher altitude, easy or not easily for you to breathe? Inhale, exhale, inhale, exhale. Easy or not easy? Density, correct. So can you tell me in more detail what happened with the density, higher or lower? Wow, Vashini, not easy. Why not easy? When we want to inhale, seems like very difficult for us to breathe, right, at a higher altitude. This is because lower density of the air particle, correct. Okay, we're talking about the density of A. Okay, we're talking about the air particle because they're trying to propel the A. So we're trying to relate it with A here. Okay, see? Propel, why we need to propel the A with a greater speed? This is because when we going to the higher altitude, the density of A is less at higher altitude. Okay, that means that the air particle is less. The air particle is less. That's why we had to breathe. Okay, so they want to let here momentum equals to m times v. Okay, the momentum they need to maintain. Okay, they need to maintain the same momentum because this momentum actually will provide the force, what, right? The force for the weight, for the weight and the upward force that we provided must be maintained at 2 times 1.4 Newton. That means that in order to maintain this weight to move up, upward force must be equals to the weight we need to maintain. So your change of momentum, this one should not be decreased, it should be maintained. But now the problem is in higher altitude, your mass of the air already decreases. Already decreased. So in order to achieve back to the same momentum, we need to increase the speed. We need to increase the speed. Is it okay? Okay, because momentum divided by the time actually is the force. The weight of the object is already a constant number. Okay, it's a constant number. So in order to able to stay at the positions, we need to maintain this value. So we need to increase your speed. Is it okay? Mass of the air particle, actually less air particle already. Less air particle already. If okay, then let me know. If okay, then you type yes. Thank you, Fatima. Vashini, thank you. Okay, Fawal, thank you. Kai Chen, thank you. John Ho, thank you. Okay, dear, this lesson already complete. So this one is self-practice, and I will provide the answer also. I will provide with the detailed working step lah. Okay. Then since we still got 6 minutes, it's okay. We're trying to continue with lesson number 11. We just entering small part. Okay, easy part. Like boys and girls, take out your lesson 11. This is about non-uniform motion. Okay, drag force actually is always trying to oppose your motion. So the drag force, you need to be very clear where is the motion direction right now. Then drag force always drawing in opposite way. Okay, so example of drag force, for example, viscous drag and then air resistance. Air resistance we very common okay. Then here, drag force will always increase with the speed. So imagine if you, let's say you are walking, you don't feel the air resistance. But when you start to run or you're sitting inside your car, you're trying to move out a little bit with your hand, but this is dangerous lah. It's just example. You can imagine you're sitting inside your car is moving, so your hand is moving up. You can experience the higher air resistance. When you are walking, you can't feel. But when your speed is increases, then the drag force will increase. Okay, when you slow down, the drag force will slow down. So can you see that the drag force is always oppose your motions. So this one is the direction of your motion. It's telling you that the ball is moving downward. So at here, your drag force must be opposite to the motion. Motion going down, then drag force going up. Okay, so for the car also the same. We got drag force. Can be the air resistance, can be the frictional force or whatever, okay, to oppose your motion. So if your driving force is greater than your drag force, then object is accelerating. That means that speed up. If the drag force equals to your driving force, then this is balance force. Still remember just now, balance force. So the movement will be constant speed. Okay, if already moving, then it's constant speed lah. Then this one, if let's say the drag force greater than your driving force, for thrust force moving forward, then this case will be deceleration. It means that slow down. Okay, it's slow down. So all this is related with the drag force. Okay, then we go to your page number 2. Second question first, more easier. Okay, we look at the second question. An air bubble in a tank of water rising. Keyword, highlight. Rising, that means that where is your direction of motion? This is your direction, going up, rising. With constant velocity. Yeah, constant velocity. So again, Balance force. So what's going on? Okay, the force acting on the bubbles are X, Y, Z. Okay, like boys and girls, try to choose the question. Try to choose the correct answer. Up thrust is the upward force. Up thrust is the upward force. Upward force X. Then what is your Z? Z. Let me check the answer. Well, almost there, but not the answer. Fatima correct. Washini correct. Yeah, Fawal correct right now. Prasan, no, Prasan, no. Constant velocity, highlight constant velocity. Vito almost there. Bubble, you imagine bubble. Bubble weight is big or small? Bubble mass. So at here, constant velocity, boys and girls, constant velocity is resultant force equals to 0. Upward force equals to the downward force. Let me check. Prasan. Prasan, no. Constant velocity. You highlight constant velocity. Resultant force is 0. Then upward force equals to downward force. Like Boyang, let me check. Boyang correct. You think? You think no? You think constant velocity? Vito correct. Prasan correct. Kai Chen correct. Lydia correct. Okay, constant velocity highlight. Then resultant force is 0. Upward force equals downward force. So upward force is X. Must be equals to Y plus Z. Because we got 2 downward force. Okay, so this one A and C confirm. B and D confirm wrong. Okay. Then why we choose here Z is the weight. Because bubble, the mass is very small. So this should be the weight. Then viscous is actually the Z. Yeah, the bigger one, this one. So answer should be A. My dear, answer should be A. Then we goes to one more question before we end our lesson. So here, a small ball is held at the surface of the liquid of the container. The ball, okay, starting like this. Then here, the ball, we release from rest. U equals to 0, and then it fall. Highlight the fall. That means this is the directions going down. This is the directions. The ball has a velocity. Then the force, drag force, F acting on the ball. So A, B, C, D, which one you think is the drag force? So you think the drag force, what's going on with the drag force? A, B, C, D, which one is the correct answer? Prasan, you give me the answer is for this question 1? Or actually it's just now question. Oh, it's for question 1. Good job. Yes, correct. Your answer is correct. How about others? Let me check. Fatima, correct. Very good. How about others? Bawang, no, the force will decrease. Drag force will increase or decrease, you think? When the ball going down, at start, not moving, of course, no drag force. Okay? Then you think the drag force should be increase or decrease. Vito correct. Kai Chen correct. Washini correct. Okay, dear, look at this. So when the ball going down at start, it should have no drag force. So this one confirm wrong. D confirm wrong. Okay, then after that, when the going down, the drag force will start to going up. Okay, So going up, that means that increases. So when the speed increases, the drag force will be increases. So it won't goes to decrease. So this one C is wrong. But then A and B, which one why we don't choose B? You see this one from here, then at the end it going down. So this one also wrong. Answer should be A. Answer should be A. Okay, so this part is wrong, it going down. So this part is going to the zero. That means that it increase the drag force, at the end decrease the drag force. No, D is wrong. It's at start, before we release, it should not have any drag force. Drag force will be increases when the speed increases. Okay, so until here, next week we will continue this lesson and also lesson 12. Okay, any question? If no question, our lesson will be end at here. Any question?